We talked about regular versus reverse shading. We talked about dashed lines versus solid lines. We talked about the fact that when you divide by a negative, we need to do what? We need to flip the sign, okay? And last but not least, we ended up determining, okay, how do we know where the true region is? You're listening to this part? How do we know where the true region is? Not where we're going to shade. That's going to change, okay? But if you know where the true region is, that's gold, okay? That's the most important part here. So true region, right? The true region is either below or above when it's horizontal or diagonal lines, or left or right if it's vertical, okay? So another thing I want you to realize, and I'm not going to have enough room here, so I'll do that later on. There's another way of showing whether or not a region is true or false. I'm just going to stick with a short method right now on this page, but follow me and let's do some graphing here. So page 19. For each of the following, determine the intercepts, rewrite the inequality, and then we'll graph it. So at first this will look exactly like linear equations, but then obviously we've got that inequality there. We're going to change it, okay? So let's do the intercepts. I don't like it this way. When the constant is here, I like to bring that one over to the right side, okay? So 4x minus 5y, what happens to the negative 10 when it comes over? Why do I keep on saying that? Because that is a common error that students forget to switch the sign, okay? So it's positive when it comes over. Same with equal signs, same with inequalities. Okay, here we go. Let's find the intercepts. So for a moment, I want you to imagine that there is an equal sign there, and that is the boundary line, the equation of the boundary line, right? So when I do the x-intercept and the y-intercept, I forget about the inequality symbol. It comes back later when we graph it. So to find the x-intercept, it's 4x is equal to 10. So we divide both sides by 4. That's 2.5. So 2.50 is our x-intercept. That's not an equation, that is a point. Okay. Y-intercept. It's negative 5y, right? Negative 5y is equal to 10. So we divide both sides by negative 5. Y is equal to negative 2. 0, negative 2. Okay. There you have it. Okay. So you have to imagine down the road you're going to have 2 or 3 of these. So that's why I want you to have a nice clean boxed in and intercepts, because these are the ones we're going to use to graph. Okay. Use to graph. What? Boundary line. Since you're still fresh to this, boundary line. Okay. That's why we do this, so we can graph. And that's why I reviewed equations, because it has been a while for you. And now I rewrite. I will do that underneath this. Rewrite. So I will start off with the partially rewritten format. And in this case, I want to bring the 4x over to the other side. So negative 5y is greater than or equal to negative 4x plus 10. And now I need to divide by negative 5. So I'm dividing by a negative 5. Before you do anything, before you do any math, do this right away. What is going to happen to that inequality? It's flipping, right? So I'm going to face it the other way. Okay? Flip. and then do the math. So here we end up with y, -4 and -5 is just positive, right? 4 over 5x. 10 divided by -5 is -2. We need to do this because we want to graph them on our calculator later on. That's why we need to have them like this. Now, I do a little thing right underneath this. First of all, is this a dashed or a solid line? There's no equal sign, so it's a dashed line. Okay? So if you don't have that equal underneath, it's dashed. Later on, I'll just have a D there. Okay? Dashed line. Where's the true region? If it's less than, think below. Y is less than. So true region is below the line. Okay? And we're using regular shading. So where are we going to shade? If you use regular shading, you want to shade where the true region is. So we're going to shade below the line also. So these will match if you do regular shading. Regular shading. I don't have this in my notes, but maybe I'll get you ready for if reverse shading, then it would be true is below the line. That never changes. The true region doesn't change. Where would we shade though? Above. It's exact opposite. Okay? So I will just have this on the side for you to look at. If you review this, you're like, oh, we're shading the same where the true is because we're using regular shading. If I ever ask you to use reverse shading, you do the exact opposite. Okay, let's graph this thing. So there's your, make sure you put arrowheads because I provided that grid so to get you started, and it's easier, cleaner. And let's plot the points. So it's 2.5, 0, 0, -2. I already have scales and everything. And here you have to go back to your, so read what it says here, what kind of line it is, a dashed line, correct? It's just telling you that the line itself is not included in our solution. And this is, if you get this one wrong, if you go solid, it's easy to fix. You just go in with an eraser and just erase certain sections off, and then you're good. Put your inequality right at the end here. And this is going to save you regardless of how you shade, to be honest. Label the true region. It is below the line. So everything here is true. Or you can do solution. It's up to you. So you grab your ruler and you just shade the entire pane, the region right under the line. So any point that is found in this shaded region, which goes on forever really, is a solution. So this is how you graph. You're going to practice shortly. Is 40-30 part of the solution? Let's first do this by observation. Where is 40-30? Is it even on our graph? But it would be way over here on the right side and then going way up, right? So we actually have no idea whether or not it is a solution right now, based on what we can see. So when you have a question like this, I need you to show the work, right? Show work. So substitute into inequality and check if it is true. And I would say grab the original inequality. Okay. So we've got the, I'm going to grab the very top, the original, just in case I made a mistake in rewriting it. So x is 40, correct? So you go 40 times, 4 times 40 minus 5 times whatever y is, which is 30. Minus 10 is greater than 0. That is 160 minus 150 minus 10 is supposedly greater than 0. So 160 minus 150 is 10, minus 10 is 0. Is 0 greater than 0? It's not. It's false. Therefore, not a solution. Zero is not greater than 0. Maybe I'll make a note here. Note, is 0 greater than or equal to 0? There you could say it's true, because it's asking, is it greater than or is it equal to? When you have this, this is true. This is just a side note. So it's this inequality not having that equal sign that makes it false. Okay. All right, try the next one here. Plug this into this inequality and see if it's part of the solution. Yeah. Give it a try. By observation, okay? Just by observation. Is negative 2050 even a possibility? Imagine negative 20 would be somewhere here, 50. Like, you're definitely not going to be in the solution region, because if this is true, this is false. I don't label the false region normally. I just focus on the true region, but anything up here would not be a solution. Okay. So let's just for note-taking purposes, so it's 40 times negative 20 minus 5 times y minus 10 is supposedly greater than 0. That gives you negative 80 minus 250 minus 10. If you do all of that, you get negative 340 is greater than 0. This is false. Okay, not a solution. There we go. So don't just guess. Don't just say yes or no, because there is a 50-50 chance, right, for a point to be part of the solution. Let's go to the next page here. What do you notice about that inequality? Only x. So what kind of boundary line are we looking at? Think of it this way. X is always something. X is always something, right? So it's going to be a vertical. It's going to be a vertical. Have that on your study sheet if you struggle with it. So special case. Only x, right? Therefore, vertical boundary. It's just a note for you. Okay? So in that case, you don't need to find the intercepts. Okay? No need for intercepts. You just rewrite. So we're going to take that And I'm going to bring that x over to the other side. Okay. 3x minus x is 2x is less than 6. We divide both sides by 2. It's not a negative, right? We're not divided by negative, so everything stays the same. So this would be x is less than 3. Okay. So vertical line going through 3, 0. Right? It goes through 3, 0 on our x-axis, but it keeps on going up indefinitely. So let's do what we normally do. Dashed, right? This is a dashed line. Where's the true region? If it's less than, you have that on your study sheet maybe, but less than should be you should be thinking left when it comes to x values, right? So, sorry, not below. I go left like this. True region is to the left. And where are we going to shade? We're still using regular. We're shading the exact same region than where the true is. Okay. So this one is actually fairly straightforward. You just go to 3, 0 and make sure it's a dashed line. True region is here. And I'm going to shade that one. So these ones are fairly quick to do. Is 4, 7 part of the solution? This one you could do without, you could probably tell me right away. 4, 7, where's 4, 7? 4 is here. It doesn't even matter if it's 7 or negative 7, but anything to the right of the 3, right? If the x value is bigger than 3, it just wouldn't. So you use this one. So what's up with that? Is there any spot for y? No, so just ignore it. Just put the 4 in wherever there's an x. So 3 times 4 is less than 4 plus 6. That's 12 is less than 10. That is false. So don't be thinking every time it's going to be false, okay? It depends on the scenario. False, so not a solution. In fact, you can pick any point you want on this grid, plug it in. So what I picked 4, 7, right? Let's say randomly I picked 4, 7 right here. You plug that point into the inequality, and if you end up getting false, you know this is false, right? Like everything that's in that region, because the boundary line is kind of like what splits it. So if you pick that one, you plug it in and it's false, you know everything in that region is false. Okay? And vice versa. If you had picked, a point here, let's say negative 5, 7, you plug it into your inequality and you get true, then you immediately know that all of this is true. Okay, so there's ways to check if you're doing this right or not. Okay, I'm going to pause here and let you try a few. So let's go to page 23. So I'm going to break this down into 2 parts. First, we're just going to graph, and then I'm going to go the other way where you have a graph. Now you need to write the inequality. So let's start with this first. So find the intercepts, rewrite it, graph it. Okay? So let's try on page 23. Let's see how far we get. I don't want to say stop at a certain point. Just keep going as far as you can. We'll give it a 10 minutes or so, 10, 15. Some of you are still working, I know, and there's more for you to try. Let's try 2 together, and then I want you to practice the other way around, like from the graph to the inequality. Okay, that's what we're going to end up with. Okay. So you should on your study sheet have a reminder of where the true region is, right? You should tell yourself, how do I find that? When is it solid or dashed? All of those things. So let's figure out the x and y intercepts. Sorry, this should be 10. -5, 0 is my x-intercept, and 5y is equal to 10. Y is equal to 2, so 0, 2 is my y-intercept. Okay, so that's first step. That's for graphing purposes. Rewriting it, you get 5y is greater than or equal to 2x positive, because this comes over adding, plus 10. Divide everything by 5. Y is greater than or equal to 2 over 5 x plus 2, right? Because it divides both of them. Now I know that it's solid because of the equal sign there. The true region is where? It's greater than, right? So it's above. And I'm going to shade above as well. So for now, we're sticking with regular shading. Okay, so this would be, make sure you do all the steps, right? X, Y. -5, 0 is right there. 0, 2 is right there. Is it supposed to go up? My slope is positive, right? So it verifies that what I'm doing is correct. And just make sure it's a solid line. Okay. There you go. Label it. Y is greater than or equal to 2 over 5 x plus 2. And true region is over here. That's the best way to make sure you get this right, if you tell me where the true region is. Okay, and in this case we're using regular shading, so that's it. Okay, that'd be a good graph there. I'm going to post the key to this, so I will skip the second one, go straight to the last one here. What is that? Just y, right? Special case, horizontal. You just bring this over. So it's y is greater than 10 minus 4. Okay, it comes over negative, so it's just 6. So horizontal line. Goes through 0, 6, right? So dashed. True is where? Above. We also shade above. So just go to 6. You guys did see horizontal lines in intro, right? You should have. You need to go talk to your intro teachers. What's going on? What's happening? Okay. Y is greater than 6. And I'm just going to shade up above in this case. There you go. And there's a lot for you to try. We didn't have to flip the sign. Notice that. So it comes in from time to time, but not all the time, right? So but be ready for that. So 23, 24 is game for tomorrow. So make sure you practice those. So I'll write that down at the top of this in case you forget. So I'll just go page 23 to 24 is on graphing. Okay, graphing only those 2 pages, or does it keep going? Never mind, it goes to 25. Easy fix. There you go. If you are having a hard time, you should do more. If you have a pretty good idea after a while, you can do less. Let's go back in time a little bit, a few pages. And if time allows, I'll ask you to continue to graph. But I need you to go to 21. Yes, 21. Writing inequalities from the graph. This is okay. These are the steps, okay? You don't have to follow them to the T, but in general, I find the slope I find where the true region is. I ask myself, is the line dashed or solid? And then I write my inequality. Okay. So, and remember if the line goes up like this, the slope should be positive. If it goes down, the slope should be negative. Okay. That's just a quick reminder. If it's a horizontal line, your equation will be y only, right? If it goes up or down, it'll be x only. So that's just a quick reminder. So here we go. Let's look at this line. And I've given you points. I don't know if you can see them there, but this is the y-intercept, which is what? 0, 4, right? And let's scan the line until we find another occasion where it perfectly crosses a grid. And I give you the point right there. And this is what? 3, 8. Now you can use the slope formula, but I don't think you need to. Okay? In this case, my slope is what? My slope is going to be positive or negative? From left to right, this is going up, right? So it's positive. Then just count. Well, how many are you rising? 1, 2, 3, 4. Okay, there's a 4 rise. And how many are you running? How many units? 1, 2, 3. Okay. The run is 3, so you just go 3 like that. So there you have your slope of the line, positive 4 over 3. So you could keep going 4, 3, 4, 3, 4, 3, and always land on the line. At the same time, you could do the opposite. You could go back 3, down 4, back 3, down 4. You'd still get the same line, right? Regardless, this is your slope. Because if both are negative, right, down 4, back 3, it still is a positive slope, right? Both negatives turn into positive. Okay. So you got your slope, and this is a diagonal line. So this would be y blank 4 over 3x. And what goes here? What is this? The y-intercept, right? So let's figure out our y-intercept right here. It is 0, 4 right there. I'm going to highlight that. That is the coordinate of the y-intercept. We only take the 4, right? We take the y value and determine that. It's positive 4. So you just go 4 over 3, slope x, plus 4. So we have everything we need in terms of the boundary line. This is now the tricky part. So let's do what I keep on doing here. What kind of line do I have? Dashed, right? Where is the true region? Right there. Above or below? Anyone? Below, right? True is below. I don't worry about the shading. I just care about the true region in this case when I go this way. So which way should my inequality go if true is below? This way or this way? If it's below, you want this. Can I leave it like that, or do I need the equal sign? It's dashed, so no equal sign. It just stays like that. And there you have your inequality. Let's do one more. You know what? I'm going to let you swim right away. Sink or swim here. Try it. Do the parts you absolutely know are true, that you know how to get. Find your slope, find your intercept. Try to put it together. See how you do. Otherwise, you're going to fall asleep on me here. All right, let's do this. Slope, intercept. I try to give you points that it's a little easier, but if I don't, you would want to scan and see where it crosses the grid perfectly in the corner. If you're doubting, you should be able to replicate that slope over and over. But in this case, I'm going to use, let's see here, if I pick this one, I scan, I think this is it. So that would be a 3 and a 2, right? 2, 3. So let's keep going, see if we can do that again. 3 and 2, we're landing on the line again. So now you know for sure that that's your slope. So this would be 3 and that is 2. What kind of a sign will my slope have? If you look at the line, it's from left to right, it's going down, right? So it's going to be a negative. My rise is 2. My run is 3. So that is the slope of the line. My y-intercept is 2, 4, 5, right? This is 0, negative 5. This one right here. So it's negative 5. So now you're ready. It's a diagonal line, so it'll be y, negative 2 over 3x minus 5. And it's solid, and the true region is above. Okay. So I'm going to go greater than, and because it's solid, I'm going to have the equal sign as well. So this is what the inequality should look like. So solid and true, like this, is exclusively for your inequality. Same over here. Earlier I had dashed and true. That is exclusively to come up with that inequality. Everything else is just basically from the line. Okay. Special cases. Special cases, then we'll do a mock AC before you go. See if you know how to do that one. I'm not going to take it in, but we're going to pretend like it's an AC, because that's what you're going to expect tomorrow. Determine both inequalities. So let's call this inequality A, and let's call this inequality B. Special cases, right? Let's do A first. A is what? It is a vertical line involved, right? So will we have a y in there at all? No, it's just going to be x. Where does it go through? Let's do the coordinates. That's 2, 4, 6, 7, right? It goes through 7, 0. So what number is going to be on the other side of the equal sign? 7. There we go. And now you do the solid. And where's the true region? Look at solution, don't look at the shading, right? It's to the right. So you look at your study sheet. It should be going this way, right? And you have an equal sign because of the solid. So again, and if you want to highlight where did I get the 7 from, I got it from the x-intercept. For B, horizontal line, not a diagonal, right? It's horizontal. So there's only going to be y there. Only y. Maybe up in the vertical here, only x. So I know it's going to be y. Where is it going to go? What's the number here? You just go look, right? This is 5, 6, 7, 8, 9. So this is 0, negative 9. This point right there. So you know this is going to be a negative 9 here. And you know this is dashed. And the true region is below, right? Because of this. True region is below the line, below the boundary. So I know that it's going to go like this. And no equal sign because it's dashed, right? So again, all of this just for the inequality. Those are actually fairly quick. Like, you don't need to show a whole lot of work. I'm showing you a lot of work here because you're still new to this. So expect me having a bunch of lines on the same grid and then just go grab the information from it, okay? So this is the mock AC right underneath this. Could you find the inequalities for each one of those lines? And the point of intersection, that's a bonus. Let's call this one A right here. Somewhere along the line, we're just gonna call this A, and this is inequality B. So make sure you have A and B done separately. Find the inequality that would represent the graph. For A, I'm going to use the points that are provided. 5, 7. So it's a drop of 5, a run of 7. My intercept is 11, positive. So solution is above and it's dashed. That would be my inequality for A. For B, I'm using the points that are provided, 1, 2, 3 this way, and 1 up, right? So I know my slope is positive because it's rising from left to right, and it's going to have a rise of 1 and a run of 3. My intercept is -7, so it'd be y is less than or equal to, because the solution is below, 1/3 x minus 7. Could you find the point of intersection? You type this into y1, this into y2, and here's the answer if you wanna try this. This using the calculator, that's the point of intersection. Please try the pages. What I'm going to post is basically 23 all the way to the end of that package. So you learn how to write the inequalities as well. So graphing and writing both, okay?